The triangle inequality states that any side of a triangle must be less than the other two sides of the triangle combined. So if we take an example here of a triangle with sides 14, 10 and 6 can be drawn. You can see pretty clearly the longest side here, 14, that is clearly less than the other two combined. So it's less than 10 plus 6, 16. Okay, and clearly the shortest side, 6, is going to be less than. And if you think about it, right, we take our sides 10 and then 6, the longest path that you could make would be 10 plus 6 is 16, but anytime you then move this 6 anywhere, right, it's then going to be less than the sum of those two together. So this theorem then makes sense. Why are we talking about this with complex numbers? Well, the triangle inequality is useful because it can be used to consider the distance between points in the complex plane. So let's have a look at how that goes about. So let's take our two complex numbers here. We've got z and w, 4 plus I and 2 plus 5i. So if we were to plot them on our Argand plane here, our complex plane, we've got these. If we look at z plus w, we know we can do it algebraically. What does it look like geometrically? We've got the z here, and then we'd add on the y, the w, which becomes that one there. Okay, so our z plus w, that would look like, let's go with blue, that would look like this line here, right? That's our z plus w there, which corresponds with our 6 plus 6i. So 1, 2, 3, 4, 5, 6, and then we're going up by 6 there. And you can also see that if we did it the other way, if we went with w plus z, then we get that one there, and we make a parallelogram, okay, because we've got our two triangles on either side, and now we can consider our z plus w. So using abiding by the triangle inequality, this blue line here, the z, the modulus, so representing that as the length of z plus w, that is going to be less than or equal to the length of z here, which we represent by the modulus of z, plus the length of w. Now again, it would be equal to, we talked about before, if they were collinear, so they were all on the same. So we went z and then w like that, but that's not happening there. We're looking more at making a triangle, so it's less than. Now, that's probably the one that we know and love the best, but you could also look at, what if I looked at z here, right? Could we say an inequality from that? So if I had z would be less than or equal to z plus w here, right? So z plus w plus, now because I'm going back the other way, right, I'm going back this way, it's not plus w, it would be plus minus w. So that would be that, except when we take the modulus, then, you know, that just makes that positive because we're talking about a length and we're not going to have a negative length. Okay. Similarly, you could do the same thing for w. You could say that the modulus of w is going to be less than or equal to, so this would now be minus z because we're going the other way here. So remember, tip to tail, so we'll be going that way and then that way. So we would now have, that would be less than minus z plus the length of w, and once again we're not looking at the negative length because we're talking about lengths, so we could just say it's like that. Okay, so all of these are correct, but this is probably the one that, this one is the one that is used most often because it makes the most sense. All of them are saying and repeating, reinforcing the triangle inequality, that the length of any side is less than or equal to the sum of the lengths of the other two sides. All right, so that's how it fits with our complex numbers. We can consider another case, that being, what about if we want to find an expression for the modulus of z take w. Okay, so we're looking at, this represents the distance between the points representing z and w there. So let's go back and consider our the vectors that represent our complex numbers. So we've got z going along this way, and then we've got the minus w because w was going that way. So now we're going minus w, which makes this here, that would be our z take w. Just write that there. Okay, so we can confirm this, that z take w would be 4 plus I minus all of this, so minus 2 and minus 5i. So we end up with 4 take 2 is 2, take 4i, and if you have a look, across 2 and then down by 4, so that corresponds. Similarly up above, this would be the same as if we had minus w plus z. So if we went with minus w first, okay, that would be going down here. Okay, so minus 2, minus 5, and then we're going up here. So that's our z there. Should put in my minus w over here. We can see once again we make this parallelogram, and our z take w is the same length there. Now, looking at our triangle inequality, once again, we can now say that the length of z take w is equal to z, the length of z, plus the modulus of minus w, and again we're looking at that is a length, so that's just going to be there. So that's another oh, and when we said equals, we don't mean equals, we mean it's less than or equal to. Sorry about that. So less than or equal to there. And similarly, like we did before, if we looked at taking z as that length, right? So we could go the modulus of z, that would be less than or equal to, again, go tip to tail, so it would be that one, z take w, plus there. So we will look at, that would be less than or equal to the length of z minus w plus w, but again, we're talking about the lengths, so we can get rid of that negative there. And you think, well, that's great, and I can do the same with the w, but with this, we can rearrange this to get z take w by itself, the length of that, to get another little interesting property. So if I was to take the length of the modulus of w on the other side, we get that, which is less than or equal to the length of z take w, and therefore we have the modulus of z take w, watch where the greater than or equal sign, the inequality sign is going, the open end is there, it means it's greater than z take w. So from this triangle inequality and looking at complex numbers, we get three really useful properties. Those being, from the original, we've got z plus w is less than, so that was pretty straightforward. And then we've got the difference between the 2 points there, that is going to be less than or equal to that. And then our last one, which is quite useful also, is that we can say that the difference between that length is going to be greater than or equal to if we took the length of z minus the length of w. Now, you know, we could do that the other way around and say w take z, and so technically, if we did that and w was the longer length, again, we're looking at a negative length, so we would technically have the modulus of all of that because we're just taking the positive sign. So hopefully that shows you a little bit of where our triangle inequality can be useful with some properties for complex numbers.